I'm going to tell you, the way we connected with him was under protest, because his colleagues actually drug him into a couple, actually really big research projects of, 400 and 500 kids size research. And they brought you in. They're very, very skeptical, man, about how a clapping machine could affect a kid's ability to read. And after those studies, another convert, it happened with statistically significance. I can't explain why these numbers changed, it's how he told it to me. And I was like, really? You think that too? Oh my gosh. So, since then, long story short, he's continued to work with us. Our friendship with him has grown. And he helps us consult with other researchers, so we help them make better designs. A lot of times researchers are good at collecting data, but not necessarily crunching that data. Again, Dr. McGrew is awesome at that. He's also a bit of a renaissance man. He started a website before websites were even, they were just kind of getting off the ground. And it's become one of the most traveled websites, most visited websites on the web about human intelligence, and it's called IQ Corner. And if you want to know something about intelligence, you'll probably find it there. And it's categorized, and he blogs about it, and it's very cool. And it's just been upgraded. And then he's created another kind of a sister site, I guess, brother, sister. Anyhow, and it is called The Brain Clock. And it's all things timing as it relates to neurology and the brain. And so this is why I'd like to introduce Dr. Kevin McGrew, or as we like to call him, the Time Doc.
Thanks, Matt. We did not get off on a good start. No, we got off on a good start. I was extremely skeptical. And I'll get into why that is. It's really awesome to be here. I did 2 presentations before at IM conferences. I'm gonna put the lavalier on because I tend to sometimes get a little animated and start kind of gyrating around the room. And last time I presented in 2006 or 2007, I think it was kind of an audition, and I haven't been asked. I thought, why haven't I been asked to come back and speak at an IM conference? And I've learned they haven't had me for 5 years. I didn't know that. I thought you have it every year. I'm working with you guys, and you're going to bring me back out. So it's like I must have not done a good job or something. And now I know the reason why. My presentation is, I'm going to get right into it. Before I do, I got to ask you for a few degrees of freedom. If I get a little scattered today, or if my brain freezes for a couple reasons. My wife and I have been in the last 5 days we've traveled stayed in 4 different cities, been in 4 different airplanes, been in 4 different hotel rooms, and I've been transported on vehicles that have 4 wheels, 6 different type of mechanisms there. We've been up at 4 o'clock 2 of the last 3 days, and we slept in 1 day to 6 o'clock. This has not been it's been a very eventful journey to get here, because I originally was coming here to present, and I got just so you know, kind of other things I'm involved with. I provided a declaration in a death penalty case in Texas about 4 months ago for a person who's mentally retarded, or a person with intellectual disabilities, and then I was supposed to represent me in court. And then like a week ago, they said, we want you to come down and testify. I said, I can't. I'm going to this conference and presenting. But it kind of worked out. So I got on the phone, rearranged the schedule, rearranged the flights, and went down and spent a half a day with a high-powered lawyer team prepping me and taking a 37-page declaration and reducing it to 7 pages on the spot. Next day, going to court, sitting in court all day, being on the stand, being cross-examined by the district attorney. So my brain's a little fried right now. It's what they call the Atkins MR death penalty hearing. So that's why the schedule got a little crazy. And it's also why I need to apologize for why I'm not going to be here tomorrow, where I said I'm going to be an expert panel, because in the process of making the changes to the reservation, I just somehow spaced out when I agreed to do that and changed it to go back on Sunday. And I'm not changing my reservations again, because I've done it like 3 or 4 times now to get here. What I want to talk about, well, first of all, I want to introduce my lovely wife in the back. She's not expecting this, and she'll probably kill me later. Will Diane stand up? say with Diane is our personal metronomes are on the right-on zone 99.97%. Okay, that's all you need to know. I think, therefore, I am, which is a takeoff on the Rene Descartes, the philosopher. I think, therefore, I am. And some of you who maybe grew up in the 70s might remember a Moody Blues song about it starts off, I think, therefore, I am. Of course you are, your magical star. Troubles, I forget the rest because it was in the 70s. One of my favorite songs, though. But a more accurate title would be I am, therefore I think better, related to, I've had an epiphany. I've been trying to figure out what's going on with I am since I got drug into the study. Really, I had a colleague drag me into that first 2007 reading study, which was published in Psychology in School. Gordon Taub was the leading author. And we did find some significant results that a clapping machine, which I was very skeptical, made significant improvements in reading, especially the fluency and efficiency and automaticity of reading. And I was like blown away, like, how can this be? And we wrote an article. Gordon was one of the got study going. Dr. Tim Keefe from the University of Austin, Texas, was the stat guy. And I was the guy who had to write why it worked. And so I started digging deep. And you can read this personal story in the I Am Home blog. I blog there occasionally. I started searching through the literature, and I could not believe the stuff I was finding on mental timing, brain clock, and with all these different fields. Some of you have heard this before. You heard me in 2006 and 2007. Yeah, there's a few hands. I look younger than I did then, right? But I was reading stuff from developmental psychology, from biological psychology, molecular psychiatry, the psychology of music, cognitive neuroscience, and I'll tell you, I have good general intelligence, but trying to get into this stuff and then trying to link it, there were some common themes going on. And I said, there is something here with this technology, and I actually tried it when I was down with Gordon down in the schools down there, and I go, this is different than some of the prior treatments we did in special education, which were thoroughly debunked, like Dolan Delicado. I don't know if some of you might know that, but kids have to crawl, or take an 18-year-old and make them crawl again so they can read. That was why I was originally skeptical. So I said, there's something here. Well, it ain't exactly clear. Who knows what band that was? And it was Buffalo Springfield. I'm trying to see who's with me. And so Buffalo Springfield is the group that had the members that eventually turned into Crosby, Stills, and Nash and Young. Okay. And my prefrontal cortex is a week today from all the stress, so I may never get to a slide. And so, then the next thing that happened to me, where's Ian from? Oh, we got to talk. She knows more about my I Am home performance than anybody in the world should. Because about, a year and a half, 2 years ago, Matt and Nicole came to Minneapolis, and they basically said, we're going to give you the I Am home, you're going to go home and do it. And April's going to be my therapist. April knows that I can't dance. I don't do very good on the foot tapping thing. And she knows what my issues were with the I Am home, but it was an epiphany for me when I started doing the I Am home, actually doing it. And because I got on the machine, it didn't take me long to get on target. And then, my mind started to wander, oh, no problem, get right back on. And I don't know how we had the communication, but I'm an extremely visual spatial learner, and I'm a numeric guy, quantitative guy, quantoid. So I was looking at the screen, and I was looking at the visual feedback and the numeric feedback. Okay? And eventually she said, no. You need to stop looking at the screen. And because I'm not very good at auditory processing stuff. I have some issues with reading and writing and spelling, and I think I'm dysgraphic if they would have had it back in the day. And I can't spell with crap. So I had to turn around and close my eyes and oh my God, my I Am performance is tanked. And I found myself, even at times, chasing the wrong tone, I call it. It was telling me that I was too far off on the side of the metro. So I started to chase that. You know how far field you get? I mean, I'm serious. And then all of a sudden I go, laser beam and shut down what I have as a very busy mind. And I'll get into that. And it really gave me some insights that I was reading and writing about controlled attention, working memory, executive function, focus, but it really didn't connect personally, and that made a huge impact on me, made me understand the literature and what IM is doing, and it's really going to push what I'm thinking in my current thinking about what IM is all about. So, a little introduction of who I am. This is a picture Bacall gave me to represent who I am as a time doc. You can read my Vita, but these are all, you have all these slides, right? I have a newer version of these slides, and I'll get them either post at the IM page, or at the Brain Clock blog, or at the Mind Hub. And I do a lot of different things. But my conflict of interest disclosure is Matt said I consult with Interactive Metronome to help other researchers and try to understand why this thing works. Have a new web portal what the Interactive Metronome helped me put together, which puts all my internet resources. I have a web page. I have 3 professional blogs actually, and I put all together in a place called the Mind Hub. And that's, if you want to find out what I'm doing, it's basically my brain on the internet, because I can't deal with it internally. I have to put it out there. And it's just go to the Mind Hub. The 2 major blogs related to today are the Brain Clock blog and IQ's Corner. Matt already mentioned. I have presentation philosophy. You need to know this. And it basically is an old man, I'll paraphrase it, and a boy and a donkey were going to town. The boy rode the donkey, and they walked past some people who said, it's a shame the old man makes walking and that boy's riding the donkey. You don't have these slides. The man and boy thought, I think you're right. So they changed positions. Later they passed some other people. Said, what a shame that he makes that little boy walk. You know what? This is not working. But closer. Is this oh, I didn't turn it on. It's not? Okay. And they decided, past more people they thought we could go walking and use a donkey to ride. They both rode the donkey. Run around, they go along, travel along, they go, what? It's a shame he puts such a hard load in that donkey. They said, you know what? They're right, so let's carry the donkey. They crossed the bridge, they lost the grip, the animal fell into the river and drowned. So what's the moral of the story?
He's a cat. Flushing the toilet, 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 he's a cat. Flushing the toilet. He does not care if he's wasting water. He likes to push the handle and watch the water go down. He's a cat. Flushing the toilet, 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 he's a cat. Flushing the toilet.
It's a cat. increasing, especially, there's different networks in the brain, functional networks. There's about maybe 5 of them. One of them deals with executive control and working memory. It's the parietal-frontal lobes in particular that I'm focusing on. And if the parietal-frontal lobes are working more efficiently, they're communicating better, the signals going quicker back and forth between them. It improves focus and attentional control. This is working memory. Most of you know what working memory is, right? It's your mental workspace. You're using it right now. You've forgotten 10 slides ago. Just like flushed out of there. It's a limited capacity thing, and you're using it right this moment to process what I'm saying. Look at this, and you're trying to, and the more you can focus on me and my slide, you're keeping things in there. This starts to go out here. The message, the stimuli are coming. You're going to lose it. And so this is kind of like a 3-part explanation of what I think is going on in simple terms, in terms of I am not going to explain to you today. Increased brain timing, temporal resolution results in more neural efficiency, which results in network communication between different functional networks that deal with different aspects of the human function is more efficient, quick, more synchronized, more efficient. And in terms of what I'm interested in specifically the parietal-frontal areas, how they work together in cognitive tasks, which increases the efficiency of working memory, executive function, and attentional control. And that is why we get these outcomes in the areas of reading, language, and having cognitive tasks. I think it's really exciting. So since I had a problem with that first video, I don't know if I'm only do one more video. In fact, no, I'm not. I'm going to just save some time. So I'd have to do one, right? How many have heard about the Human Connectome project?
Now you've heard of the human genome. Well, please allow me to introduce you to the Human Connectome, the first ever, not quite finished, map of the human brain. Our brains, like the rest of our nervous system, are made up mostly of neurons. Neurons are basically like a normal cell with a cell body and a nucleus and all of the usual organelles. But one thing that makes them different is long branches coming off them called axons. These serve as pathways that allow signals to travel from neuron to neuron. The outermost layer of our brains, called the gray matter, is responsible for all of our cognition, and it mostly contains neuron cell bodies. But deeper beneath that is the white matter, which sends signals from one part of the brain to another, and it's mostly made up of axons that act like your brain's wiring. Until recently, neurologists thought that white matter was just kind of like a plate of spaghetti, just a bunch of wires randomly connecting different parts of the brain. But in 2005, neurologists with the National Institutes of Health and a number of other US universities set out to make a map of all of our neural connections for the first time. They called that map the Human Connectome. Their research uses a one-of-a-kind MRI scanner so sensitive that it can detect the movement of water inside individual neuron fibers to show where they are. And then it uses a high-resolution technique called diffusion spectrum imaging to see in what directions those fibers are oriented. To get pictures like this, a traditional MRI machine would have a test subject sitting in the machine for more than 7 hours. Now they can take these pictures in a matter of minutes. And what they're finding is that instead of being a bunch of neurological spaghetti, these fibers are actually organized into an orderly 3-dimensional grid with fibers running up and down and left and right with no diagonals or tangles. Scientists describe it as sort of like the layout of a big city with streets running in 2 directions and elevators and buildings going up and down.
These are white matter tracts in the brain. This is the underlying infrastructure of the brain. And there's some controversy about whether these are, because of the methodology, that these may not be anatomically correct. But what they're finding is that there's these white matter tracts, which is an infrastructure, communication system that the cortex sits over, all of the lobes we talk about. And this is where all the communication is going on. And there's an extreme amount of explosion of research about white matter tract integrity. And that this is kind of the brain information superhighway. And how good the white matter tracts for a person, how they're functioning, helps with different networks work together, different lobes work together more efficiently. And that's an extremely important thing to understand. And white matter matters is a key I'm time doctor 2. He was the original time doctor. And these are pictures of Jim. I never met the man. He passed away, but recently his wife got in contact with me. And he had this, a card and a picture, and he became known as the time doc in his clinic. And that was the story Matt was giving you about the young boy with prosthetic. This is what the original iron machine looked like. I want you to look at that. Here's a cord. That's the plug you put into the outlet. So that gives you a scheme of the size of the original technology, which goes out on the analyzer and training system. Now it's in a little, I am home, it's in a little white box. It's smaller than an iPhone. And Jim, I've read some of his original papers and such, and they're available through a blog post that I own. That developed this to help musicians with their rhythm so they could be better musicians into what's called the cook. But they found unprecedented improvement with kids with disabilities, debilitating cognitive and physical-based disorders. And Matt gave you one example. And chance favors a prepared mind. And Jim Cassidy, I had learned post-hoc, that he had a purpose, passion, and he serendipitously discovered that this thing that he developed with musicians was helping people. And there's this, I'm not going to go through this thing about serendipity. I think it's a very important thing. Basically, this is a quote YouTube got in there that he was somebody who stumbled into something, but it wasn't by accident. And when he saw it, he knew that he had something that was not just there. And other people would have missed it, would have drifted by the port of opportunity. He saw it, found it. So let's get down to really getting to that's what I want to get into today. Is that this is what bothered me when I first started getting into interactive metronome. How can that machine result in increased reading performance, mathematics performance, help with ADHD, help with tennis, help with golf, help with language? How can you produce positive outcomes? As a cognitive psychologist specialized in learning and intelligence, that is unheard of. That is hard concept to understand. And then there have been now 2 different reading studies that have controlled experimental and control groups. One for Tell and I developed Tim Key, published in 2007. You can get all these up later. And this current one, this new one here, it's not even out yet. It's online. It's online. It's called First Alert here. It's online. It's not people can mail it. Matt was talking about. So we got these 2 studies. And how can an ion help with reading and other outcomes? And the way I look at it from my field is if you're going to have positive outcomes across different cognitive and learning domains, there must be a general, we call domain general mechanism. That means if you work on one thing in the brain that helps a lot of different areas. That has been the whole search for the holy grail in intelligence and educational psychology. Yet the opposite is domain-specific learning. So if I went out and I want to practice my card writing, for 12 weeks, I'm going to practice, really focus on my card writing skills. I'll get better. Is that going to help me with reading? Probably not that much. But I am is something that I do. It helps me with my driving, my reading. It's like the domain general thing is going on in the brain. And that is really intriguing. And that's just more of a definition of it. You've got this slide. And my hypothesis, this is just a standard kind of explanation of working memory and how things are processed in the brain. And this is, I was talking with Matt and Nicole, and I am both using this complex visual diagram to try to explain interactive metronome. I've simplified it since then. But I think the domain general mechanisms that are being impacted are very consistent with what was shared personal story. Is that it's working memory, cognitive processing speed. Because of your neurons are firing more efficiently, it helps with that. How? Why? Potential control and focus is the key. And I'm actually going to skip these 2 slides just to catch up. Here's the stuff I want you to look at and go, would this help me explain task and focus, stay in a right-on cognitive zone with attention for any more than 20, or the maximum is almost 20 to 30 minutes that you can do. That's not that for the general population in terms of, there are people who do a lot better. And why is it difficult to stay on focus of attention, which is conceptually similar to what the right-on zone is doing? It's difficult because there are external stimuli going on in the room. And the real thing that I have learned, there are internal distracting stimuli too. And when I was doing IM and April was monitoring me, that was my problem. I would get really good, doing good, watching visual feedback. My mind would start to wander. I have internal stimulation distractions. And I call these the attentional pirates. They basically are, you're trying to stay, you focus on attention on a cognitive task when you're trying to read or something, right here, but attentional pirates like Black Sparrow. Jack Black Sparrow? Oh, Jack Sparrow. I'm mixing up with them. Comedian. Okay? Let's go on. Look, here's the attentional pirate. You're trying to stay on when you're trying to do a cognitive task, you're trying to stay in that zone. But the pirate, either an external stimuli or something self-generated. A lot of them are self-generated. Will push you out. And then you lost focus. Okay? When you're doing IM, when you get out there, what does the IM do? It goes beep, and basically you're out. You're too far this way, you're too far this way, and then you get back into the zone. And the goal is to stay in there as much as possible. Don't let the intentional pirates steal you. And that's, to me, is the simple explanation. IM making you focus and shut down all that self-talk. There's a name for that, and other distracting things. Like Nicole was here doing, and she got a really good target there, the golf ball again, and Matt's talking away. I mean, she has shut that down very good. So I focus and control attention, working memory, executive function is where the action is at. That's the third level explanation. And I think that's where we're getting better control of our attention. We're taking control of our focus to stay on target. And what is really important about that to me as a psychologist who specializes in the area of intelligence is that there's a huge amount of research that says working memory capacity is highly related to intelligence, in general intelligence. Okay? And these are just some articles. Working memory is almost perfectly predicted by G. Working memory might be the underlying general cognitive capacity that makes you more better in terms of general intelligence or being able to cognitive tasks. These are some correlations that I thought I at least kind of live up to my name and throw some numbers up there. You don't have to worry about the figures, but it shows that the correlation between working memory and general intelligence. We scored the range like 0.5 in one study, 0.98. That if working memory is kind of the bottleneck, the most important cognitive construct for being able to use your intelligence most efficiently. And Randall Engel and Kane and Conway have probably got the best, I think, model of working memory. And it says that working memory capacity is executive attention. I'll get into that more, which is focus. If you can focus, you can keep the red dots, the thing that you're supposed to be focusing on in your working memory, and not get distracted and focus on something, you do better. And that's what I think IM is doing with cognitive fitness kind of tools. So in this, we've got these two reading studies now that have come out. So in the next slide, the red dot, think of that as a sentence that a child has just read. It's read and they've read it into working memory. I've got a more simplified model now here of, somebody's reading something and they're coming, the senses pick it up, they take these sort of visual features and stuff and kind of, use perception, put them together into words, and then you get the sentence into your focus of attention. And if you're reading, you want what you're reading to be staying in your working memory and not being pushed out by random thoughts. Oh, I got to do this next, I got to take the trash out, that kind of thing. Or there's a noise that just went off in the classroom or something. You want to stay there because if you're reading something or working on a cognitive task, if it's in active area of focus within working memory, that allows you then to use long-term memory to bring your information you currently know, something that you've already learned, bring it into working memory at the same time while this stuff you're focusing on, and attach it. That's how you learn to remember, get something in the not working memory, it's not getting attached to prior learning. Those are external distractions. And now, this I think is a really important insight that I've had, that there are internal distractions that are going on. It's called there's an explosion in the area of what are called brain networks. Instead of thinking about the brain as a modular thing, well, there's this lobe, there's this lobe, there's this cortex. Now we're talking about there are networks that work together. Parietal and frontal in particular, cognitive things, and focus. Very important. There's a network related to reading, and they all kind of sometimes work together. And a lot of times those networks, those lobes are not working together because when you're in a resting state, you're just laying around sitting, not thinking about anything, your brain is active. That's called the default mode, default network. And we spend 40 to 50% of our time during the day in the default mode. It's called mind wandering. There's different terms for it. Rest, rapid episodic spontaneous thinking. Tuts, I like that one. Task unrelated thoughts. But the more generic term is mind wandering. There's a huge amount of literature. Yes?
That's during waking time? 40
Yeah, this is during waking time.
Yeah.
Yep. Not into sleep studies. Yeah, and this is the average. Some people are different than others. And of course, there's a hypothesis and research that suggests that people that have like a bipolar or in manic stages, their default brain network is way too active. And there's even stuff called schizophrenia might be related to this kind of stuff. ADHD kids has been now being called by some researchers as a default mode network dysfunction. There's too much internal generation of stuff going on that's distracting the kid. It's not so much external as it is. It's too much. I have a very busy mind. That's my problem I have at first is my mind's always busy. To shut it down is really hard. And that's it. IM teaches you to do that though. You can't stay on target. You can't stay there. Once you get a target, you think you're doing good. For me, my mind starts to go elsewhere. And what happens? I can't say it, but that damn IM goes hammers me and says, no, you're not going there. You're not going there. You're not going there. Oh no, you're not going there. And because I don't have the controls to do that, but it teaches me those controls. When I'm in IM, I prefer to leave questions to the end. It was really hard for me to shut my mind down when I was doing that. And I've never been able to do that my entire life. And I got to epiphany, like, wow. And that's kind of like getting into the zone, getting into the accordion, or getting into the flow, whatever you call it. And it was like a new experience for me. I can shut that thing down. It's been dominating my brain all my life. There's default brain networks good for creativity and stuff. Sometimes you need to shut the damn thing down. In the early days of brain scan studies, they do the resting state MRIs and stuff for people in the scanners and such to get the baseline, they call it the baseline, which was now called the default brain network. Then they'd subtract that out of when a person engaged in a task in the MRI machine. There was noise. We want to know what these other areas do. Now they're realizing default brain networks is important in its own right to be studied. It's part of us. It's part of what makes us creative. Thinking your mind wandering, doing various stuff. And it's also related to a lot of psychiatric and neurodevelopmental disorders when there's too much of that going on. So it's a mixed bag kind of thing. You need to learn how to. IM teaches you how to control the external distractions, which is the easiest part. Shut down the self-talk and the mind wandering is the hardest thing. That's what I think it does. And the analogies I like to use, I don't know if any of you remember the comedian Stephen Wright. He'd stand up. He'd make these statements. And then this quick little one-liner, kind of philosophical. Dead candy words. I don't know that. I think he's still alive. He doesn't look this good anymore. But he captured the essence of the default brain network because I was trying to daydream of my mind go on, that wandering. That's the essence of the default brain network, and which is good. It's got a good side, it's got a good side and a dark side. And you want to daydream and think about things like when you want to be creative, when you're doing something that really requires cognitive focus and attention and high level control. You don't want that to go on. You need to shut that off, and that's what the IM is doing. Basically, what it is, this is the working a lot of working memory. And it makes you inefficient or makes it hard for you to make connection with prior learning long-term memory. It just doesn't get in there. And IM helps you stay in focus and get Jack Sparrow out of the picture. So, we have internal and external pirates, and they're both coming trying to get, that's what you're trying to do when you're trying to focus and learn. When you're sitting here today trying to listen to me, and if you got tight underwear, it's distracting you, that you're my word, what I'm saying is getting out of there. Or you're starting to daydream, and then all of a sudden you're like, oh shit, I didn't pay attention, I just missed something, this guy talked way too fast. I gotta stay focused, I gotta stay in there. And these, you've got stuff going on in the room trying to distract you. You've got stuff coming inside of your brain, the default brain network, that is distracting you. And there's a lot of that going on. And so what IM does, I like to use graphics, is teaches you to stop that. Don't pay attention to that. Don't pay. That is hard. I'm sure I'll preach to the choir here. When you first do it, that is really hard to do. It's really hard for me to shut my default brain network down. But that's what I think is the primary explanation I give to people. It shuts those things. It teaches you to have control of your focus of attention, or we can also control attention on demand. You don't want to be focused on things like this 100% of your day. That's impossible, and actually it's probably related to some kind of disorders like kids with autism and such who get so super focused on something that they're way too focused. You want on-demand focus. You want to be able to turn it on and turn it off when you need to. And I have another analogy. I like analogies to explain to people. You need to learn how to detect, which is the executive function. You need to, when you're working on a task, you need to know, oh, my mind's starting to wander. Stop that with that. When you need to learn how to detect and then deflect distractions. And so another way to look at it is Interactive Metronome puts a sustained and contained focus shield around your working memory. And this time I've got Superman. This is the original Superman I watched as a child. And what was happening? Bullets, he could stop running faster than a speeding train. Bullets would bounce off him. Well, Superman, IM helps bring Superman in to say, stop external distraction, stop internal. I'm putting a force field around this working memory and this focus of attention, and I'm staying focused. So I repel so you can excel. I'm getting into sound bites. Matt's always asking me, can you simplify that? Give us something that will make people understand what you're talking about. So that's what I'm trying to do today. That's what it does, though. It trains your brain to do this because you can't do this. What I think the beauty of Interactive Metronome is, it basically serves as a prosthetic for your frontal lobe for a while. Yes, it basically sits on top of your brain, and it says, go, get back on, get back on, get back on, get back on. So, and then after a while, when you get really good at it over time, you can wean yourself out. So when you're out in the real world, you're meeting, you're at a conference, and you're trying to focus, you can now, without Interactive Metronome beep saying, well, you're off, you've learned that, oh, get off. And it's almost automatic. And you get right back into the zone of attention. But for a while, some of us need a prosthetic on our brain. And that's what I got. It's like, I need some scaffolding, I need a tool that train me how to focus. Because most we don't get that otherwise. Do these work for you? So, kind of summarize the major points of level 3 of explanations, which is that to me it's all about, and I really like your presentation, you talk about all these constructs. Working memory, executive control, which is metacognition, thinking about your thinking. You basically want to stay on focus as much as possible. And it's my research-based hypothesis now to me that this is what IM is doing. That it's affecting a domain general cognitive mechanism, which we know from the research in intelligence learning is working memory and executive function, primarily frontal lobe, parietal and other things. That's why we can see it affects across reading, language, math, and other cognitive tasks, because it's making this domain general cognitive mechanism work better. You can be more efficient with your working memory, you can control your focus. You're in charge of it now. And I want to point out to Matt that I was speculating about this back in talking about these things back then. Didn't have the big picture put together, but we had it. So, there's a huge explosion of research right now that studying the default brain network is a hot topic in neural areas. And we talk about mind wandering and quiet mind and touch. I'm just showing you something. This is like the year 2012, and this conclusion is this is really kind of a bridge from the working memory stuff. This research of mind wandering is part of failure of executive control. You don't have a good, most of us don't have a good, or some of us are better at it, ability to shut distractions down and know when we're getting off target or not. We don't have an interactive metronome strap or ahead when we're doing tasks. It's like, look, you're off. But it trains you, and mind wandering is a failure of executive control. And there's more articles about this. People's minds are sometimes wander during cognitive activities. And people with lower working memory mind wander more frequently than people with higher working memory. They kind of work together. If you get better, if you control your mind wandering, your working memory increases. In fact, the efficiency of your working memory increases. I'm not going to show this. There's some cool bits of data, but I'm just only these are studies. This one just came out in the last couple of weeks. You can see people are don't worry about these boxes, but they're relating focus of attention measures, which is kind of like what the IM is actually a good measuring system for measuring focus. It's kind of one measuring system. And doing research and relating things such as executive control, focus of attention, to reasoning, high-level abstract thinking, fluid intelligence, general intelligence. If you look at these numbers here, focus of attention in this study had a path of 0.79 to reasoning. What does that mean? When you use measures of focus, the ability to control attention, that there was, for every standard deviation change in focus of attention, there was a 0.79 standard deviation change in reasoning. Now, you're going to put that on scores that are more similar to you, like IQ and reading scores at a mean of 100, standard deviation of 15, or most of your assessment instruments do that. That means that focus of attention was on that kind of scale, and you move the needle on attention 15 points or one standard deviation, you get a point, that would be 15, what's 15 times 0.8? 12. You get a 12-point change in intelligence or reasoning. That's huge. Yep. And then,
Why is it not as big? There's only 7 on the
because the focus of attention, executive function is the brain manager, but it's managing executive and attentional control is the thing that's most important that's managed. And here's another, but these are just models. Here's this study just came out in the last month also. Working memory capacity. This is explaining SAT scores. Well, working memory capacity has a significant effect on SAT scores of 0.5. That means you move the needle on working memory by 15 points, which is this one standard deviation. You're going to change the SAT scores by about 7 on the same scale. But then these people are hypothesizing working memory has a strong effect on attentional control. That's the key thing I'm trying to get across to you, attentional control, which has a significant effect on what they're calling attentional failure, mind wandering and such, which also then impacts SAT. The important thing we're finding from all this research that's coming out is working memory, attentional control work together. There's a mind manager over the executive function, and that helps control attentional lapses, especially those from the default brain network, but also those from the self-talk, and also those from outside of the environment. So, kind of summarize that bit of information. There's the research that has just been floating in the last years that there's a general stable mind-wandering propensity we all have. And there's probably a normal curve on it. Some people's mind wanders more than others. It gets into a dysfunctional state. Some people are very good. Tiger Woods used to be very good. He was known for his focus. Man, he probably had quite a high end, but his golf performance has probably changed a lot. Probably I just hypothesized when I watched. He's lost focus. They always say he's lost focus. Well, it might be internal. He has lost the ability to control things better, to think as internal thoughts. People who mind wander a lot during cognitive tasks and reading tasks have a lot of mind wandering during everyday activities also. Working memory is related to reading comprehension. I'm getting up with reading studies, because working memory reflects an executive ability to regulate and control thought, to control your ability to focus. And the theory behind it all is called executive attention theory. And I was talking about this in our 2007 paper, with Conway, Engel, and Kane, executive controlled attention. Attentional control ability, massive, make that simpler, Kevin, and they use the word focus, is a domain general system that controls working memory and default brain network and task unrelated tasks. It's a system, attentional control system. That's important. So focus, attentional control, working memory, executive function are the talking points. That's my 4-point plan. Romney has his 5-point plan. Of course, we have, what's his name, with the 999. The takeaway message from what I've gotten through so far is focus, which is another word for attentional control. Makes working memory more efficient, and is the IM personality that's working on you when you're doing it is helping you learn how to do executive control on your own at another time. It teaches you how to detect when you're getting off, and you start to learn how to do it automatically. For me, it took like 2 weeks, and I started to see the difference. And it's called executive control theory. And when I tell people working memory, IM works on the attentional control system. And that includes all of this, working memory, executive function, and focus of attention, the 3 things. That's the attentional control system, which is the most important thing for general intelligence or any cognitively demanding task. When you're trying to learn something new, it involves cognition, reading, language, not any motor stuff. But this is where I think IM is having its biggest impact. And this is the domain general psychological construct. I'm still doing good at memory. Wait, I have an alarm set, but I have my phone turned off. Don't think, yeah, actually, it should have went off 10 minutes ago. Okay. So some time dot, to summarize that a bit. When you must ponder, your mind must not wander. You've got to learn how to control it. A wandering mind is an unfocused mind. When you're trying to do something that's cognitively demanding. A wandering mind is good at times when you're trying to do creative stuff, and you can problem solve, think about things, and let it hurt. Whoa. Okay, everybody, relax. I'm going to get into meditation now. That's my reminder. That means I've only been talking an hour, and I got started 10 minutes after the time I was supposed to. Came on just right at the right time. I think teaches, well, the most important thing, it teaches you on-demand focus. It teaches kids on-demand focus. They may not understand it doing it, but when I was doing my IM, people know that I haven't done it for a while. This probably shows today. I was able to elicit it on-demand. Okay, Kevin, you need to do this now, and I can do that. These are some, engage and focus, disengage and distractions, detect and deflect distractions. Now, it was very fortuitous. I didn't plan this, but that little meditative song came on, and I'll shift gears. That there's an interesting link, I think, and I believe, between, you've all heard of mindfulness meditation. It's a huge growing area with good research behind it. There's some people who are hucksters and such out there doing it and not doing it correctly. But there's different types of meditation, and when I started reading that literature, I go, there is such a strong parallel between mindfulness meditation and IM. Have you guys made that connection yet? Yeah. And this is just an article from the Journal of Nature, and I'm actually going to skip this one. But they talk about different types of meditation, and they talk about a category of meditative techniques called focused attention meditation. And the key thing is you must sustain a selective attention and monitor moment by moment on a chosen object. This is listen to your heart, listen to your breathing. Concentrate on an object. That's the same thing you do when you're doing IM. You're focusing on stand up heart. You're focusing on the that's what you're focusing on. And that's what people who attend focused attention meditation, they say they're trained to breathing or something. It's the same concept. And this practice helps people learn to regulate their attention, which is basically what I was saying about IAM. It teaches you to monitor your ability to remain vigilant to distractions. It teaches you to, people who focus attention meditation, learn how to go, oh, I'm getting distracted. Oh, maybe something else here, or something internally, shut it down. That's what they do, and after a while, people who are really good at meditating, learn these skills and learn their executive functions, basically to know, oh, I gotta get back to my tool or something. So the beauty of IM is that when you do focused attention meditation, you have to learn how to detect when you're moving off, when you're getting off target, off your object. You have to learn that. I am scolded. I say, I am hammers. You're not focusing anymore. Kevin, you're over here. And I need it. You need that. So it's like that. The millisecond feedback is an extremely important part of this. It helps. It's basically doing what I think that people who do focused attention meditation are doing. It tells you when you're not doing it. So, okay, it's training you to do the same thing that people who learn how to do this. It takes a lot of time. It takes a long time to learn how to do that through meditation techniques. But I think, makes it a more fast track. Because the technology, it gives you milliseconds that you're not focusing on the object anymore, or the tone. And the psychological, that was a review on meditation effects on different things. And here it is, some more writing about the effects of attentional control in meditation and mindfulness practice. And I'm not going to read all this stuff, but basically it's saying the same thing I'm saying about what I think is going on with IM. Focused attention meditation is all about learning to monitor stay on something, and when your mind wanders, get right back on it. And that's what IM is doing. And it has positive, that type of meditation has positive impacts on a lot of social and emotional variables. So these are the red dots up here: anxiety, mindfulness, stress, behavior, and cognitive things such as perception, attention, intelligence, working memory, and stuff. It's the parallel findings that we're finding with IM. So, I think there's a huge amount of literature coming from the default brain network research, mind wandering research, attentional control research, and there's parallel stuff going on in meditation. I think it's very similar to what we're doing with IM, with the neurotechnology. Brain's almost like meditation, focused attention meditation with masses. That's a huge thing. When Matt talks about company pivoting, this is huge. You're all aware about brain fitness, brain training, and I think that some of the programs are really good, some of them are not. I think that a lot of the ones that are good, they're good because they're indirectly, maybe not explicitly, they're teaching you to get your executive control, your attentional control system. It might be a working memory task, but during that you're working on attentional control. Attentional control, some people say, is working memory. So I think that's why IM has stumbled into the brain fitness market. It has something that is probably one of the best technologies for brain fitness and brain training, and it's better than the other ones because they are indirectly are not focusing just on the most important thing, which is controlled attention. I'm going to give you a little bit of level 3, level 2 stuff now. These are some time bites, better thinking through brain thinking, fine-tune your networks, and white matter matters. And this is kind of the big epiphany that I've had last year. And this is, I've already showed you this, and the concept here is we're increasing brain and neural efficiency. Neurons are running more efficiently because of the timing of adjustment of the clock. And the hypothesis I have, basically, it's coming from all these other studies, and it's very consistent with what Lonnie Nelson is going to be talking about this afternoon. We're going to deep connect what I do with what he's talking about. Is that we're really more, we're making the communication system within the brain primarily the white matter tract level. That's the wire link from the telephone system in the computer. We're making them work more efficiently. And there's now evidence that we might be growing. I say that again. I am maybe growing white matter tract. You know how important that is? Lonnie will talk about that, and he's got some evidence to that effect. That is extremely big. That if you've got this well, let's speak beginning of little white monitor stuff, which is connecting all the different networks, making this parietal-frontal network work together better, making the networks related to reading working together. Why? How can that be? Because the white matter tract is just a conduit. Your WD-40 in that, and you're growing more. That's huge. That's basically what I just said there. Attentional control system gets better. If you're interested in learning more about all this brain network stuff, that's where the neurology, neural stuff is going. It's not so much about what lobes, what's happening, it's about brain networks now. Networks are more efficient. The Human Connectome project, and I showed you this one there. I put some stuff with the Mind Hub, if you want. I clip notes. I take stuff out of journal articles that I read, and I put them in a little PDF file. And they're huge, but here's one. Your brain is a network. The Human Connectome, another brain research. It's a notebook. Last time I updated it was 8.12. It's available to Mind Hub for download. It's a big thing. This is really probably a pivotal study in 2010 in Trends in Cognitive Sciences. That's another journal. Most of us don't know it. But the gist of this is they're basically saying the current way to think about the brain is networks, different networks, but there are primarily three that are most important. One is called the default brain network. I already talked to you about that. And that is, they call it endogenously mediated self-regulated mental activity. Mind one, TUTS, task unrelated thinking. Primarily about mental, medial, prefrontal cortex, and the parietal cortex. Over here we have the central executive network, which is incoming, primarily incoming information is coming in, and you need to learn and you need to process. You need to use your working memory. You need to think. You need to problem solve. Research suggests that network is primarily deals with the frontal and parietal cortexes. And that's very important. And we call that in research in intelligence, an integration of a large number of neuroimaging studies. It's now a theory of intelligence called the PFIT model, Parietal-Frontal Integration Theory of Intelligence. And when you hear Lonnie talk tonight, I'm guessing he's going to be talking about parietal-frontal lobes. I think PFIT. And that's the working, that's what I showed the diagram. That's the working memory, executive function. That's when you have to really work on something in your brain badly, trying to learn something new with your child or your age. And in the middle is what's called the salience network. Interior insulet and the anterior cingulate cortex. That's the controller. That's the air traffic controller of the brain, which is basically mediating between should I be in default or do I need to shut default down and go into thinking mode and keep my central executive network. In my world, there's the old cartoons. You used to have the guy sitting there and then one angel over here saying, yeah, no. The devil, no. It's the same kind of thing. You've got these two networks that are repeating. The default, which is let your mind wander, which is good at times, but sometimes that's too much. And over here is one that the network that is, I need to be in charge. I got to learn something now. I got to focus on reading. I got to exam tomorrow. The salience network is the task switcher that basically says, okay, shut this down over here. Invoke this one. So that's the one that is the dynamic switching between the two. I think IAM is working on these networks. It's helping control these networks. Probably in particular, it helps shut down the default and better activate the PFIT, the parietal-frontal, and through the salience network. So it fits, what we're doing fits really well with current research on brain network activity. It's important to recognize that the network model is the new model, new way of thinking about the brain, versus the modular model that we all got trained on. Well, this lobe does this lobe does this. That's still important, but it's more important that lobes and different lobes work together as functional units. Some for cognition and reading, some for thinking, there's different things. I don't have time to show this video right here, but you can blog about it. It's at I Am Home. It's a person who's a good meditator, and they show the brain activity of this person when they're just in a restful state or watching a video. When they're not meditating, in the same brain, watching doing the same task when they are meditating, and you see distinct different patterns of the brain. They're just doing different regions of being activated. Because when you learn how to meditate, when you learn how to get focused to do I am, I think that you're getting the brain to work differently. White matter matters, which was the big epiphany for me. Is that's what I think is going on. I think that's what Lonnie's going to be talking about. And I've been writing a bit about the Parietal-Frontal Integration Theory of intelligence, because that's my area. But I think it helps explain what we're doing is the frontal lobe, interactive metronome, and what it's doing for people cognitively. The frontal lobe together with the parietal, but especially the frontal lobe, especially the dorsolateral prefrontal lobe, are working together and are involved in short attention, working memory, executive functions. I am a tool that seems to exercise all of those and make you more efficient with your working memory. It helps you, once the I am is removed, the setting is gone, you learn how to get back on target and how to monitor yourself. And then the critical thing, the most critical, is you get the focus of control of attention. You keep the red dot in working memory, in whatever you're thinking about, in working memory wrong, and you don't let Jack Sparrow take out. Either your internal Jack Sparrow or your external Jack Sparrow. These are just more slides, and and this is from a different perspective. This is a summary of the P-fit model from the book called Human Intelligence by Earl Hunt. And this is his model, seeing the same thing. That we focus attention internally or focus attention externally, and what is it? What lobes of the brain control these things? The frontal lobe, parietal lobe, and anterior cingulate gyrus, and they all come together to help impact how working memory is, and you want to stay in there. And that allows you to do general reasoning and bring information you've learned before in and work on it. And the attentional pirates are always trying to take control of these things and get you off. And IM helps to train your brain to shut those down so you can keep on target there and not have this thing bouncing all over. I just put these up to show you that I know. I read these things. And this is the P-fit model if you want to read more about it. This is the really cool thing that's right down about pretty good. Is that the P-fit model talks about here's the frontal lobe, here's the parietal lobe, but there's this thing here, the white matter tract. And I don't know if I'm going to see this correctly because I'm not a neuro person. I wish Lonnie here to correct me or somebody else. It's called that arcuate fasciculus tract. How do you say it? Fasciculus? Yeah, see, I read these. Fasciculus. Thank you. Is it arcuate, right? Arcuate fasciculus? Arcuate fasciculus. Arcuate fasciculus. That's the primary communication, primary white matter tract from the frontal lobe to the parietal lobe. And that's important. And there's some research coming out basically on white matter tract integrity as a neural foundation for general intelligence. And I'm not going to go through this, but they've done studies recently, and these are really cool diagrams. If I had time, I'd be sitting here playing with these. They have these biomarkers. Life knows that they've measured three different aspects of white matter tract integrity in brains. And this is the important diagram down here. And they have found in these studies that the integrity of a person's of white matter tract integrity measured by three different indicators results in better cognitive speed, which then results in better general intelligence or cognitive functioning with a effect size of 0.8. That's huge. That means if you increase your cognitive speed by 1 standard deviation, or if you want to think about IQ achievement score, that's 15 points. General intelligence or intellectual functioning or reading comprehension will improve by about 12 points. By white matter tract integrity, wow, is it good or bad? So I'm interested in are the reading studies that we're finding that there's now 2 with IM that are pretty substantive. And this came out 2 weeks ago, this article. And I was so excited about developing a white matter tract integrity in reading. And look at this diagram. I'm going through this quick. You don't have these slides. I got 2 weeks ago. Look, you see this little blue thing right here? won't give you the mnemonic I'm thinking of. Fasciculus. But it's basically saying, in reading, when we're doing white matter tract investigation reading, is that the communication between the language areas, Wernicke's areas, Broca's areas, the language centers, are people who have reading disabilities or dyslexia and don't have it, there's poor communication between that network because of the arcuate fasciculus. I almost said that again. Okay? Interesting parallel. Because what I'm looking for is there's got to be some general domain and general thing we're doing in the brain, a very fundamental dimension of the brain that I am doing to have it help reading, help this, help that. And so it seems to be a white matter tract. And this tract in particular, I won't even say it again, I'll just say this one, the AF tract. White matter matters, and this is basically the same what I just said, that they're concluding that when they compare reading disabled versus non-disabled kids, that network, not the parietal-frontal, but that's still involved, but in the language network system, and the communication, it seems that some of the reading disabilities may be explained, not all of them, by white matter tract integrity, which is the communication infrastructure that IM seems to be, we think now, it seems to be making more efficient, maybe growing network. So it helps, that's why we're seeing work across so many different domains. And so here's my comparison slide of the AF tract. This is from readings, looking at reading people and the reading networks that are working together. And this is the PFIT model, which helps explain cognitive function and working memory and more cognitive things, but it was also related to reading. It's the same underlying white tract. And I'm really interested in Lonnie. I don't know if he gets into that particular tract, but he's talking about white matter tract that I am is moving the needle on white matter tract and making it more efficient. And I think he even said might be willing to say it might be growing. That is huge. So this is my final slide, which I already gave you, and it's to summarize that we've got the brain clock. I think the underlying thing that the IM is doing is at the most basic level is letting you flush your neurons quicker. It's a cat. Flushing the toilet, it's a cat. Flushing the toilet, okay. Just think that. It's increasing the resolution of your time clock. Some watches only have a resolution of 1 second. More precise ones you get, the more expensive ones that have it in milliseconds. That's what's happening. It's fire quicker. That neural efficiency, this is my working hypothesis, is resulting in different brain networks working together to get the communication between them is more efficient, either making the white matter tracts more efficient communication somehow, or we're growing them. And I'm particularly interested in the parietal-frontal because it relates to intelligence, working memory, and other cognitive tasks. But it might be helping other networks too. It might be helping those networks relate to gait and motor function too, via white matter tract. And as a result, in terms of cognition and reading and those kind of things, it's allowing your working memory to be more efficient to keep the focus in here. And so you can bring new stuff in at the same time you're thinking about learning it, and so you're improving your focus and attentional control. So the underlying message is, I think, the cognitive component of IM is helping you with working memory, primarily by helping you focus of control attention system, shutting down the mind monitoring, helping the screen out things. Superman, I am the Superman coming and saying, hey, wait, I need to focus. The underlying things that are going on is that I think what's going on is white matter tract integrity being improved, the more you can grow, and that primarily because I think it's helping the neural efficiency. So that's how I would explain it to somebody now. I hope that helps. It ties together like a broad array of research across a broad array of disciplines. This is how I only put the slide together. I don't know, is it in your handouts? Okay, so about a month ago. That's it. That's the whole thing. I hope that I've gone fast. And so, more, like I said before, better title for my presentation is I am who I am. Therefore, I can think better, basically. I can control my mind better. I can control my working memory. I can be the master of my focus and attention. Turn on when I need to. Turn off when I can't. And temporarily it serves as it. And some people need more of it, and some people need less.